This is the second part of set operations. We're going to start out with De Morgan's laws. And De Morgan's laws are going to generalize set theory in a way. They're going to generalize some Venn diagram operations for us so that we can have those and never have to think about them. So for all sets A and B, here's what happens. A union B complement, so not in A union B, is equal to A prime intersect B prime, and also A intersect B prime is equal to A prime union B prime. So here's what happens. It's basically like the distributive property. When I distribute the complement to each of the A and the B, then the sign flips over. When I distribute the complement to the A and the B, the sign flips over. So that's what happens. So this leads us into Venn diagrams for three sets. Now you're really going to have to pay attention to what's going on here because we're going to have A, we're going to have B, and we're going to have C. So this is A, B, C. Notice what happens. I now have 1, 2, 3, 4, 5, 6, 7, 8 distinct regions going on here. Because of the way they intersect, I can have the intersection of all three of them, or the intersection of just two of them, what's in each set individually, or what's in the universal set. And so when we talk about equality for expressions for these, it's going to be a little bit more complicated. The order of operations still applies. And so when I start to throw in all these parentheses and things like that, it's really the same as having the order of operations. I have to do what's in parentheses first. And so when I'm determining set equality here, I'm going to label my A, B, and C. And because I am comparing two sets, I'm just going to go ahead and draw out both of them to begin with. Try to match these up. I like to give myself a little space when I draw them so that I can make sure I can have room to color. And I'm going to use the same sort of colors and crosshairs kind of setup that I did before so that I can, make sure that I've got my sets correct. When I look at A union B intersect C, I'm going to do this part first. So B intersect C is going to be the part that is between B and C. So it's just that little part that's shared between B and C, B and C. And the union of that with A is everything in A and everything in this part. So I need to color everything in A. And so when I do this, notice what happens. Here's everything in A. So it looks like this circle with a little bit of a tail off of it. Now, if these sets are truly equivalent, then this second one is going to look exactly like that. So let's see what we get when we do that one. Start with blue again. A union B. Well, A union B really looks like this. The union of A and B and then I need to do where it intersects with C. Well, here's the intersect with C. Let me grab red here. So what part am I talking about here? The part that I'm talking about here is just this part with the red and the blue in it. The part that I'm talking about here is everything. And so you'll see the difference is the part over here is the union of everything. The part over here is just the intersection of those two pieces. So these sets are not equivalent. Let's look at this next example. Like I said, guys, this is something that's going to take you maybe a little bit to fully grasp. but we're going to continue to work with it so that we get this concept down. This is going to help us when we talk about data and groups of data. I'm going to label my A, B, C again. A, B, C. And let's look. Start out with blue. B intersect C. Well, B intersect C is this part here. And once again, I'm going to unionize that with A. So once again, that looks like the circle with the little tail. And let's look at what we've got here. This one's a little bit more complicated because I've got two sets of parentheses. But let's look at A union C. Here's A union C. It's everything in A and C. And if I use this kind of pinky color here, pinky purpley, I'm going to also do A union B. Here's A union B. Well, if you saw what happened right there, I am going to be finding the intersection of those two sets. Well, where's everything that's colored in pink and purple? It's this part. That's got pink and purple in it. And it's also this part, which is pink and purple. Well, if you'll notice, this part over here is what I want. So this is what I'm looking at. Everything that's colored over here. And everything that was pink and purple here is green. So yes, these are going to be equivalent. Equivalent. All right, so that's how this works. It's an art. It's logic. You got to use your brain. You got to use your critical thinking skills. But it's something that we're going to work on. So take those notes and make sure you've seen this. If you need to roll it back, do that, and we'll see you next time.